The reason why you have your IKEA manuals and stuff like that isn't because, Joe Schmo over at Sweden and IKEA is writing these things. It's because the Industrial Revolution happened. The second Industrial Revolution wasn't just about machines and manufacturing. It was also the beginning of technical communications. Between 1870 and 1914, the U.S. economy exploded. You saw railroads being propped up, telegraphs coming around, and mass production. Sewing factories and all other kind of factories, stockyards, things like that. That meant a lot of this complex equipment started coming onto the scene, and growing realization that, how do you do this? Like, what do you have to operate this? Like, how do you train somebody to make textiles, or properly pack meat, or send a little thingamabob to the guy across the country to make sure he gets your note telling him to go check his backyard or something like that. It really started with the birth of technical communication. So, what the hell is technical communications? At its core, it's the practice of translating complex technical information, things like schematics, blueprints, engineering talk, the way they talk, into something that you and I can kind of understand. If somebody's going to tell me to look at the thingamabob in the steam engine or something like that, how am I going to know what the thingamabob is? You got to explain it in some terms that, a dummy like me could understand. So that's really the main point of technical communications. In the early days, that meant, like they were doing ink drawings on linen, and later like blueprinting and things that engineers kind of did to maintain consistency across the board, so that, if I show my other engineer friend, he doesn't look at me, like dumbfounded, and he can actually follow what I am trying to say and trying to convey. The biggest reason why we have technical communications and the way that it started earlier on is actually because of the U.S. Patent Office. Yeah, the U.S. Patent Office essentially required these inventors like Samuel Colt or Thomas Edison to send in detailed diagrams and written explanations of what they were doing. This essentially shaped the way the entire writing style of technical writing was. You essentially had to mix equal parts of legal mumbo jumbo and technical mumbo jumbo so that people like you and I could understand it. Samuel Colt, the guy that invented Colt firearms, he documented all of his firearms and things like that, his schematics and whatever, with descriptions that essentially read like a manual. It was like one of the first ever manuals ever. Thomas Edison, his lab at Menlo Park became a machine, not only for inventing things, but also documentation. Every invention that he had, the phonograph, the electric lamp, whatever he made, essentially was recorded in notebooks, drawings, and instructions so that people could recreate these things or fix them if they need to at his lab. They didn't really do this for fun. They wanted to patent these technologies so that they could, own copyright over it so that nobody infringes on those things. They were writing 4 patents, 4 lawsuits, and 4 product launches. They had to advertise these things too. By the end of the 19th century, technical writing had just really started to take shape as a profession. It wasn't really as widely known back then. Organizations like the American Institute of Electrical Engineers, AIEE, also what we now call IEEE, were publishing papers and setting standards. They were really trying to create a common engineering language. Machines came with manuals. Those manuals were dense, written by engineers, so, it had a lot of jargon that only they could understand. But, eventually we started to see a shift from that engineer-specific style of writing into a more commonplace style of writing. I mean, that started because of the war. The reason why these engineers started to shift away from talking to other engineers and things like that was we entered a war in 1917. It essentially changed everything. Yeah, when the U.S. entered the war, World War I in 1917, the Army had to be trained, and you're essentially taking people from these factories and things like that, and essentially telling them, hey, you're gonna have to go fight and put your life on the line for our freedoms. Most of these guys, never seen a tank in real life. Probably even let alone know what a tank is. They probably never operated a telegraph or dug a trench or a dugout or anything like that. So the military comes up with a smart idea to standardize everything. Standardized documentation. That is the key point in every form of piece of technical communications. Standardization. The War Department, also known as the Department of Defense, started making technical manuals that eventually became the blueprint for the clear, layered, and scalable instruction. They used numbering systems, exploded diagrams, and standard operating procedures to teach the soldiers and the world same methods in the same way. That form of standardization. It didn't matter if you were in Kansas or like Paris or something. If you were a doughboy, you were trained with the same documentation that was sent out. For many of these soldiers, these manuals were essential more than their rifles, because it really showed them how you could respond to, getting shelled or, building a tourniquet for your brother who's on the floor or something like that. And, this didn't go away. We have a period of after the war, the interwar period before, we joined World War II, but, when the Depression and everything was going on. After the war, America really didn't slow down. We felt it in our pockets, and so did everybody globally. But a lot of these companies, these factories, kind of roared back to life again. Industries like the automotive industry, the aerospace industry, and chemical industry really took off during the 30s. At the same time, technical documentation evolved. You couldn't really rely on some guy that's a senior or higher up to be like, hey, this is how you do this, because he might have been wrong, and you would have been doing it wrong the entire time too, without even knowing it. But because it worked for old boy over there, then it's going to work for you. You can't really rely on that practice, because if they hire somebody new or something, if some incident happens on the job, well, they're going to be like, yeah, why were you doing that in the first place? That's not how you were supposed to operate that thing. These companies needed guides, instructions, process sheets, things like that, because they wanted it to be a safer, consistent, and clear way of manufacturing or anything like that. This is where we kind of start to see the technical writer kind of come in. They were essentially the mouthpiece of what an engineer is, because they can communicate properly with everyday people. These were the people with education backgrounds working alongside subject matter experts to create documentation that made sense to the workers on the floors. And it worked. I mean, by the time World War II began, America, had become organized with standardized documentation. Millions of old recruits from the Great War and new recruits for World War II had to be trained on new technology, things like radar and new planes or new tanks, all had to be taught. And not only in English. The U.S. military was, operating on three continents. First, we, took the North African front, and then we did the European front, and then the Pacific front in World War II. These field manuals, had to be visual, had to be multilingual, and had to be readable at a glance. Army regulations, Navy bulletins, each of these, followed a very strict formatting within hierarchy, warnings, illustrations. The War Department, or Department of Defense, kind of set the gold standard for how a field manual should look. By this point, it was kind of set in stone that, hey, if you're going to create one of these things, you have to do it in this certain format so that, it lines up with all the other formats that we have. And not only was it the Army that was doing their thing with technical documentation in World War II, the civilians also had to join in on the effort. We created posters, visual aids, cutaway diagrams, even films. I mean, this is really when we start to see, video or movies, I guess, the Nickelodeon kind of, come into play. So visual literacy also became a really big tool in wartime training, because the literacy rates were not that good. They were not that good. It wasn't just documentation, it was strategic infrastructure, and without it, the war efforts on the actual fronts and the home front, would have collapsed. By 1945, technical communications had evolved from an afterthought to an industrial and military necessity. After the war, we can start to look at post-war era. The economy started to boom. This is where we get the baby boomers. Every family, the nuclear family, was able to afford a car or certain electronics and things like that. And a lot of the wartime innovations like plastic, engines, duct tape started to become more accessible to Americans. So a lot of that consumerism that Americans are kind of known for started to, set in stone in the post-war era. So, people were buying cars more often. People were buying radios, appliances, television sets, things like that. You need to know how to operate the thing. I mean, if I buy a car or a microwave, I want to know what it can do and, if it breaks, how I can fix it. So, you need instructions. I don't know how else to put it. You need instructions for these things so that people can figure out how to do these things. Not only, was it completely brand new after the war for a lot of these families to get this technology, they kind of needed to understand how to use it. It's like tossing your grandmother a cell phone or a smartphone or an iPhone or whatever and then being like, hey, use this thing. It's like, the woman's 90 years old. She probably has no idea what's going on, The average family needed to know how to install, operate, and maintain the devices because they really didn't just understand how to use it. It's completely brand new. So the manual had to teach them how to do these things. And so to keep up with demand, a new organization formed in 1953, the Society of Technical Writers and Publishers, what we now know as the Society for Technical Communications. RIP, they went bankrupt. They helped define the field. They created best practices, trained professionals, and built a network of technical writers. They didn't even stop there. Members collaborated with standards boards like ANSI and IEEE to codify how documentation should look, feel, and function like. The tech writer had gone from working in these labs with engineers and only really writing content for engineers specifically to now writing a clear, concise, modular form of communication so that everyday people could understand what they were talking about and convey a message so that they could operate the machine or electronic or whatever, fix it, and show other people how to use it. So in the 70s, this is really, really when we started to see a lot of the technology innovate on itself post moon landing. Word processors and early computers kind of crept into the workplace. They weren't as commonplace as we have now, but this is when we first start to see them getting into areas. Engineers and writers started to shy away from the typewriter because, I don't want to pull out a thing of whiteout and then retype the thing over. I just want to hit a couple of keys and then type over it again. Digital text editing was super fast. I mean, I just hit a couple of buttons and then, I could write again. Because digital text editing was so much faster and accurate and clearer, these processors, the UNIX systems and the IBM mainframes and things like that, which originally was used by these programmers and things, eventually made its way to, typewriters. And it was only a matter of time for that to happen. Software development was growing at a fast rate too, and people kind of had to document it. You had to have your guy off in the corner right over there with a notebook, being like, okay, well, this is how you do this. This is this step 1, 2, 3, 4, 5, 6. So that guy was creating guides, install procedures, and system instructions.
Do you actually believe that every home is, within the short term, the next few years, going to have its own personal computer?
Well, we base our theory on the fact that we make personal computers that can be used irrespective of location. And the home just happens to be one of the locations that the computers are used in. So we foresee Apples being used in homes, but we also foresee them being used in businesses and education, and there's an Apple going up on the first space shuttle, as you may know, to control a biology experiment.
The typewriter was starting to die out. The terminal, the keyboard, was starting to take over. So we start to look at the 80s. Personal computers started to become more commonplace now, and with them, the GUI system, or the graphical user interfaces, right? Those things really flipped the script on how technical communications was being made. Users were clicking icons instead of typing commands. Tech writers had to adapt to that. They weren't writing for specialists at this point. They were writing for everybody. Tutorials, walkthroughs, quick start guides, they kind of became the new standard in how to show off these processes, these new personal computers and things like that. So these guys, these technical communicators are starting to use these computers, these desktops and things like that. And that's where we see the rise of desktop publishing being a part of tech writing. These desktop publishing guys, gave writers full control over the layout, typography, and how they essentially did everything when it comes to manuals and documentation. And suddenly they had to become designers too. So not only were they writing things, they also had to become designers and lay out all these things of documentation so that it looked good. The line between form and content started to blur. And even more so in the 90s. The 90s, we had the internet, which changed everything.
Welcome to Getting on the Internet Easy. The Internet is the network of networks that links users around the world. It's complex and even mysterious because few people know everything about it.
Documentation kind of left the print format and went online. Help files were embedded into every piece of software. Microsoft's WinHelp in 1992 made documentation interactive. CD-ROMs and PDFs gave users searchable, multimedia-rich instructions.
Hello there. Welcome to Reveal's installation video. You're about to discover that you don't have to be a trained technician to install your revealed product yourself. It's so easy that the only tool you'll need is a
CD-ROM drives that let you access audio-visual CD programs for business, education, and entertainment.
The web gave us HTML hyperlinks and instant updates. DocBook, an XML-based standard, let writers create once. They let them do it once and publish everywhere. You know how insane that is? When you have to crank the printing press out and lay the keys out and keep hitting that thing so that you can make however many copies. You can just hit one button and it's ready. That saves you like a week's worth of time, which is insane. This is where we get to see documentation kind of more from, you know, the bland standard, hey, it's just on this one sheet of paper, here's some pretty pictures, all this whatever, into now becoming a full-fledged, dynamic, modular document. You can look at a PDF and click on things. That'll take you to another website that'll show you more things, or you can have it linked to a video so that, you know, you don't have to read everything or read a certain section or whatever. You know, documentation really started to become its own thing. 2000s really kicked it off exponentially. I mean, this is kind of where we get closer to the singularity. You know, it really started with globalization when that really kicked in. Because the internet from the 90s, you know, more and more people were being able to connect online and talk to different communities, different parts of the world, different cultures and things like that. So globalization really kick in. And the complexity of globalization also started to surmount. Documentation needed to be translated. It needed to be localized too, and updated constantly. You know, things were always changing, regulations always changing, standards are always changing, things like that, as technology also adapts. This is where Darwin information typing architecture, or DITA, came in. DITA, developed by IBM, broke content into reusable pieces and let teams manage huge libraries of content. Tools like SDL, Trados, and Acrolinks also helped with standardization and translating everything too, because, you know, I don't know if you've tried to use Google Translate, you know, translate something into Spanish and then translate it back into English and then back and forth again a couple of times. It breaks it. It does. I mean, you need something that will give you a simplified form of English into a simplified form of Spanish or something like that, so that there is no confusion between the two. And that, you know, if I explain something to somebody in English, they're able to understand that with their manual and look at the same thing, be able to understand that in Spanish. These huge libraries of content really needed to be managed. These knowledge bases essentially replaced manuals. Tech writers weren't writing documents anymore. They were really kind of creating a database. They were managing ecosystems essentially akin to what a filing cabinet was for these tech writers back in the day. So as we look into the 2010s, things got a lot faster. You know, agile development took over. Software was being updated constantly. You know, every other week you're getting a Twitter update, because that's just how it is. Documentation also had to keep up with this, you know. So technical communications adopted the docs as code model. Writers started using Git, Markdown, and version control to, you know, be able to keep track of these updates and things like that, so that they could look back and, you know, see what's changed. Or, you know, if somebody says, hey, my version of Adobe Photoshop is being buggy, well, it's like, okay, well, what version are you on? Because then you can take a look and be like, oh, yeah, well, you're on version 16.431. Let me pull up that exact file so that you can look at that. By the way, you should probably update because that'll fix it. These technical writers worked side by side with developers. Documentation became a part of continuous integration and deployment, or CIDI, that pipeline. They were essentially API document translators. Writers had to understand REST, JSON, XML. They didn't just have to translate these documents. They also had to work alongside with developers, be designers, and educators. Documentation became smarter. Writers had to use analytics to track what people were reading, searching, and ignoring, really. User experience became a huge part of tech writing because you had to understand why people were ignoring that content that they were ignoring and, shape how users interacted with the software. Every button, every tooltip, every error message mattered, and the content inside of those pieces also mattered. As we look to the future of technical communications, we see a shift from the 14-inch screen that the desktop or laptop is to a 6-inch screen that fits in your pocket. The demand for just-in-time training and documentation has become the popular form of technical communications. Going from a 5-ton supercomputer to a 7-ounce smartphone made it significantly easier to train or refresh your memory on the go. Among smartphones, artificial intelligence is capable of providing proof of concepts for developing training content.
I think the big thing to remember, though, is that artificial intelligence is going to play a role in making all of us more productive. It's not going to be replacing people, but it's going to be able to really help us work better at the knowledge bases that we have.
In fact, I used AI to help me write out the script. And this script is not entirely written by AI. I took a lot of the sources and content that it spit out, rephrased it, cleaned it up, things like that, and then put it back into an AI model so that it could kind of spit it out as a script. And then I had our proofers, our tech writers here at Ken Cook Company, take a look, clean up my language AI slop, and then rephrase a bunch of that content so that it sounded normal, I guess. But AI in its current form isn't really capable of much, but it is a really good tool at scraping the internet, getting information, writing content, which needs to be worked on. You do need to proof it and rephrase it and do whatever, and then also creating images for proof of concepts or spec work. Currently, AI in its form isn't going to take your job right now. Maybe give it 2 or 3 years. We'll see. But what it can do will save you an immense amount of time. A script like this, the amount of content that I had for this, the amount of research and things like that I did for this was essentially cut in half because I was able to go to ChatGPT or Gemini and be able to have them scrape a bunch of information, condense it for me, so that I could write that, and then also put that into a YouTube video essay format. From steam engines to search engines, from blueprints to Git commits, technical communications has been the silent backbone for every technological leap we've ever made. And it's not slowing down, only evolving.